This is not a standard inequality. There is no homogeneity, no symmetry, and no obvious trick. Pause the video and attempt this for 3 minutes. If you feel stuck, that's expected. First, we use the constraint x plus y plus z equals 1 to rewrite the denominators. Substituting these into s transforms the expression. This form is still difficult. The key is to add 3 to our expression s. Watch how this simplifies the numerators. This expression is perfect for the Cauchy-Schwarz inequality. We will apply it in angle form. To use it, we rewrite our terms to match the a squared over b form. Now, applying the inequality, the numerator simplifies nicely. The denominator also simplifies after expanding. Substituting these back gives us the lower bound for s plus 3. Wait, s is clearly positive. This is a trivial bound. We made a mistake in the application. Let's rethink. Let's go back. The expression s equals x divider plus y divider plus z divider is correct. Let's define a related sum, t. If we add s and t, we get a simple result. To minimize s, we must maximize t. The expression t equals z over by plus x over by plus y over by has a known upper bound. Therefore, the maximum value of t is 3/2. Now we find the minimum of s. Equality holds when x equals y equals z. Since x plus y plus z equals 1, this occurs at x equals y equals z equals 1/3.